Hi, I'm V, Director of Operations at Smartrek Technologies. Today in our video, we'll take a quick overview of different mesh network protocols. We'll also see a holistic comparison between a traditional mesh network and our very first cooperative mesh network technology with synchronized communication at the bit level. So how to choose the mesh network protocol that meets your demand? When it comes to selecting the network protocol for an IoT application, we need to take into account several criteria, like the specific application or ecosystem of a project. The size of the network, the required latency, the desired throughput, and the reliability are also criteria that determine the mesh network protocol that will be chosen. So in a few words, what is a mesh protocol? Within a mesh topology, all the nodes work together to distribute and transmit data to the desired destination. In a mesh network, it is said that information hops from one device to another to reach its destination. So a message coming from a device on a mesh network first sends the information to its neighbor, then the neighbor sends it to a third device, then to a fourth device, and so on. The mesh topology is generally used for major IoT applications and is essential for wireless sensor network applications, industrial automation, and smart meters management. By acting dynamically and in a decentralized way, each node is independent and it allows each device to participate in the transmission and relaying of data. Within a mesh network, everything is stable. For example, when one of the nodes goes down due to some problem, the neighboring node can take over and keep the network up and running. In fact, mesh network protocols are generally said to be self-organizing and self-healing. So systems based on this topology can reduce general deployment costs compared to other technologies like a star network. And therefore, mesh networks all allow for substantial savings in connectivity. So what are the cons of a so-called traditional mesh topology? So the biggest disadvantages of mesh network technologies is that installation and configuration is more difficult if the number of devices or nodes increases. The same thing also happens when we increase the coverage of the network. So installation and configuration more difficult as soon as we increase the number of hops. So if we increase the overall coverage of the network. So now SpiderMesh. SpiderMesh is a low power extended network protocol and therefore applies to what we call LPWAN or low power wide area networks. It's a technology that was designed from scratch and therefore it implements the lowest level of the OSI layers. What this means is that SpiderMesh defines not only how data is transmitted in the network and transport layer, but also in the MAC and physical layer of the OSI module. It's actually the first truly cooperative mesh technology with physically synchronized communication at the bit level, and this synchronization makes it possible to counter the well-known effect of packet collisions when the network size increases. This is what sets SpiderMesh apart from other traditional mesh protocols. Standard protocols, on the other hand, retransmit data in a non-deterministic way when there are packet collisions, while SpiderMesh actually allows to avoid these collisions. This is actually why we get such good energy consumption performance, network size, and reliability in maintaining communication in the network. So now the main advantages of SpiderMesh. First of all, quality of service, so reliability in difficult conditions and communication that is second to none. Next, autonomy, so low power consumption even when we increase the size of the network. Also, a long range. So as mentioned earlier, SpiderMesh is an LPWAN technology, so the node-to-node range can go up to 10 kilometers. And when it hops, given the mesh topology and given that there is no degradation with the increase in the size of the network, we literally have almost unlimited coverage. It's also very flexible, so like all mesh technologies, the network self-repairs. This gives a very high reliability and guaranteed quality of service in any difficult environment, even with high occlusion conditions, forests, mountains, buildings, underground tunnels, or through RF noise. It is also an evolutionary technology, so we can add a virtually unlimited number of nodes to the same network while maintaining the same quality of service. It's also very low cost. Like traditional mesh networks, we do not need infrastructure. It's a 100% private network, and in LPWAN technologies, it's really the one that offers the lowest total cost of ownership. So to sum up, SpiderMesh is a cutting-edge mesh network protocol that offers many advantages over traditional mesh technologies. These advantages include improved quality of service, autonomy, long-range flexibility, and low cost. And as the world becomes increasingly connected, it is important to have a reliable and efficient mesh network protocol in place to ensure smooth communication. SpiderMesh is leading the way in terms of innovation and performance, making it the perfect choice for any application.